G'day, got my DC power supply at 12 volts and the current set at 50. I've got that going to my DC generator, and if I'll just disconnect this for now so you can see how much it's consuming. If I turn it on, okay, it's on, and we can see it's 18 or 19 milliamps. Once it settles down, it's about 19 milliamps. Okay, now what I'm going to do is I'm going to feed that signal from there to this transformer. It's going to be a step-up transformer as far as amps go. So I'll hook him up. I'll just connect it at that end. Okay, so I'll hook him up and we will see that what that's consuming now. It's consuming just about 1 milliamp when that's connected. Then what we're going to do is going to connect it to this super high voltage transformer, and we will see, I'll disconnect that there. We will see that it now consumes another 1 or 500 milliamps. Then what we're going to do is we're going to put it through this. This is a voltage multiplier. Outside will be, at the other end will be DC, and hook that up. You can see that system really hasn't changed. All right. So what we're going to do now is I'm going to turn on my multimeter and show you, oops, it's now producing 40 volts, and you can see that still hasn't changed. Okay, 40 volts, and let's change it. Let's measure the current now. Current will be DC current, it's 3 milliamps. It measures out. There's a loose connection somewhere, but it's pretty much exactly 3 milliamps. Anyway, yeah, I'm just wiggling it there. So what that means is, there it is consuming an extra 1 milliamp. Right, so what that means is that from this signal generator forwards, it's consuming 1 milliamp and producing 3. It's consuming 12 volts and producing 40. Righto, so we can go and do the math on that, which I've already done. And we find that it's actually, here it is, it's actually producing 0.12 watts and it's actually consuming 0.02 watts. So that's a big difference. So it's producing a lot more than what it's consuming after the signal generator. If it wasn't for the signal generator, it would be, I think people would argue, reactive or you know, whatever, power, but definitely it's producing more after the signal generator than what it's consuming. However, we've got to remember that the signal generator is consuming 19 milliamps. So the problem then becomes that the whole system as a whole is consuming 0.24 watts, which makes our efficiency of our whole system about 50%. And most of that's tied up in converting the DC current from the output to that signal generator, converting that into DC pulse. So I hope that is interesting to you. So once again, if it wasn't for the signal generator, that is to say what our transformers are consuming and producing as a dead short through the multimeter, it's consuming 2 milliamps, and the difference consuming 2 milliamps and producing 40 volts. So what's that, 0.12, so 5 times, it's producing 5 times the amount that it's consuming in that section. So if it wasn't for that DC pulse generator, you could argue that it was over unity. Anyway, bit of fun there. Thanks for watching. Catch you later.